Hello students, in this video we will discuss about the most economical section of channels with trapezoidal shape. So the most economical trapezoidal channel is when the wetted perimeter of the section is minimum. So this was the same condition at the rectangular channel also. So let's see, in the figure you can see that B is the width of the channel at the bottom and D is the depth of the flow, that is depth of the liquid which is flowing inside the channel, that is marked on both sides, and theta is the angle made by the sides with the horizontal. So this angle is theta. So the side slope is given as 1 vertical to n horizontal. The side slope is the slope of the side AB and slope of the side CD. So that slope is given as 1 vertical to n horizontal. That is, for every 1 vertical distance unit height, there will be n horizontal units of distance. Okay. 1 vertical for every n horizontal units. Okay. So area of flow is the area of the trapezoidal shape, right? Trapezoidal shape A, B, C, D. So A is equal to BC plus AD by 2 into D. This is the area of the trapezoid ABCD. BC plus AD. BC is this side, AD is this side. The whole divided by 2 into D, which is the depth of the flow. Okay. And BC is B. BC is equal to B. Okay. Then AD is equal to sum of B and these two portions. Okay. So let's find out what is the length of that portion. That is B plus. Okay. Here we know that for 1 vertical, n horizontal. So here the vertical depth is depth D. Okay. So that means if D is the vertical depth, then horizontal distance will be n into D. Vertical depth is 1 into D, then horizontal depth is n into D. So this side becomes n into D. So there are two sides like that, CE, and here again another side. Okay. So this is also n into D. Okay. So AD is equal to B plus ND plus again ND, that is B plus 2ND. Okay. Then when expanding this, we get 2B plus 2ND by 2 into D. Okay, that comes to B plus ND into D. So we bring D to the left hand side, that is A by D is equal to B plus ND. Okay. This we can also write by bringing B to the left hand side. B is equal to A by D minus N into D. So the wetted perimeter is P, which is AB plus BC plus CD. AB is this side, BC is this side, and CD is this side. So perimeter is the length of these three sides which is in contact with the liquid, which is wetted, which is wet. Okay, so that is BC plus 2 into CD, because AB and CD are equal. So that AB and CD are equal. So it becomes 2 into CD. Okay, so BC is denoted by B. So that we have here. And CD is the hypotenuse of this triangle, which we have here, right angle triangle. This is a right angle at point E. So CD is square root of CE square plus DE square. Okay. That is B plus 2 into square root of CE is N into D. Length of CE is N into D. So N square D square plus DE is depth D. This side DE is having a length of D. So square root of N square D square plus D square. This is how CE square plus D square is written. Then it becomes B plus 2 into D can be taken outside because D is common in both the terms. Square root of N square plus 1. and substituting the value of b from equation 2. Equation 2 is this one. So from here we know that b is equal to a by d minus n into d. So substitute this value in this equation, we get a by d minus nd plus 2d into square root of n square plus 1. Then p is equal to a by d minus nd plus 2d into square root of n square plus 1. This equation we got just now. Then we know that for an economical section, p should be minimum. That is dp by d of d. This d is the depth. This must be equal to 0. That is the condition. Okay, so let's differentiate it. Then we get, in the first term we have a, which is a constant. 1 by d is there, which becomes minus 1 by d square. So this term is over. First term is over. Minus n into d. Derivative of d is 1. So that terms becomes only n. Plus 2 into d. Again, derivative of d is 1. Square root of n square plus 1 is what remains. So this is equal to 0. Okay. Again, we bring one term to the right hand side. Again, a by d square plus n is equal to 2 into square root of n square plus 1. Here, we can substitute the value of a from the equation 1. A is b plus n into d. So we substitute that b plus n into d into d. So this is the value of a from equation 1. This we substitute here. After substituting this and taking out some terms, d is common here. This can be cancelled. Okay. So it becomes b plus nd by d plus n into 2 into square root of n square plus 1. This is what we get. Then what happens is we write it as, okay, we bring a common denominator d. Okay, so it becomes b plus nd plus nd. So it becomes b plus 2nd by d, which is equal to 2 into square root of n square plus 1. So we get this equation. Then from that is from the figure, we know that b plus 2nd by 2 is half of the top width. Top width is side AD. Okay, before we calculated AD as BC plus side CE, right, into 2. That is B plus 2 into ND. This was the equation for AD before, B plus 2 into ND. Okay, so that is the length of AD. So here B plus 2 ND by 2 is half of the top width. Okay, so and also d into square root of n square plus 1 is equal to CD, which is one of the sloping sides. That is d into, d is the depth, so ND is the, here I will show in the figure, d is the vertical depth, so the horizontal distance is n into d. Okay, then the hypotenuse becomes n square d square plus d square, which finally comes to, d can be taken out, d into square root of n square plus 1. So that is what you see here. D into square root of n square plus 1 is equal to CD. That is one of the sloping sides. Okay, so this is the condition for the trapezoidal section to be economical. And also there are from this condition we know that B plus 2 ND by 2 is half of the top width, and also one of the sloping sides is D into n square plus 1. Okay, again we can calculate the hydraulic mean depth, which is M, that is area by perimeter. A is equal to B plus ND into D, that we got already. Then P is equal to B plus 2d into square root of n square plus 1. We have obtained that also. And we know from equation 16.11 that b plus 2nd by d is equal to 2 into n square plus 1. So we can substitute 2d into n square plus 1 with b plus 2nd. Okay, so this term becomes 2 into b plus 2 into nd, which is equal to 2 into b plus nd. Okay, so hydraulic mean depth is A by P, which comes to D by 2. So for a trapezoidal section, most economical hydraulic mean depth must be equal to half the depth of the flow. That is clear from this equation. Also, the three sides of the trapezoidal section are tangential to the semicircle if they are the most economical section. So if there is a semicircle as shown in this figure, you can see the dotted line here. So if the three sides of the trapezoid are tangential to this semicircle, it is the most economical section. So the proof of this is shown here. So theta is the angle made by the sloping side with the horizontal. That is, this is the angle theta. Okay, O is the center of the top width AD. AD is the top width and O is the center of that top width. Draw OF perpendicular to the sloping side AB. OF. See, this is the line OF. Okay, it is perpendicular to AB. That means this is 90 degrees. And also triangle OAF is a right angle triangle and angle OAF is theta. OAF is theta. This is theta because this is theta. That means two parallel lines which are AD and we have here EB, right? And it is intersected by a inclined line. So if this angle is theta, this angle is also theta. So that is how angle DAB became theta. That is DAF or DAFB became theta. So this angle is theta. So the three sides of the most economical section are tangential to the semicircle. That is what we have to prove. Three sides, if they are most economical, then they are tangential to the semicircle. Okay. So if we consider the right angle triangle OAF, sine theta is equal to opposite side by hypotenuse. That is, theta is the angle. Okay, so that means the opposite side is OF, which is this side, and hypotenuse is OA. So OF by OA. So OF is equal to AO sine theta. Okay, and if we consider another triangle AEB, that is AEB. Here also we have a theta, and sine theta is equal to opposite side AE by AB. Okay, opposite side AE by hypotenuse AB. That is, AE is D, which is the depth of flow. D by AB is D square plus N square D square. That is because this side is, one side is D here, that is the side AE, and this side is ND because we consider that for every one vertical there is N horizontal. So if this side is D, that is D into 1, this side is N into D. Okay, so if these are the two sides of the right angle triangle D and ND, this side is square of one side plus square of other side, the whole square root. So square root of D square plus N square D square. That is what is written here. Okay, so D is common everywhere, so square goes. That is D by D into 1 plus square root of 1 plus N square. D also gets cancelled. Hence you have 1 by square root of 1 plus N square. So sin theta is equal to 1 by square root of 1 plus N square. This can be substituted elsewhere. That is, here. That is OF is equal to AO into sin theta. Instead of sin theta, we substitute 1 by square root of 1 plus N square. So AO is the half of top width Half of top width, we already know it is b plus 2 into nd by 2. Okay, which is also d into square root of n square plus 1. This we know from the derivation which we did before the proof. Okay, so this we know before the derivation and this we got now. So this value of AO can be substituted in equation 5, which is, this is equation 5. OF is equal to d into square root of n square plus 1. This is the value of AO which we have substituted here, divided by square root of n square plus 1. Okay, so this terms get cancelled and we have OF is equal to d, which is the depth of the flow. So if a semicircle is drawn with O as center and radius equal to depth of flow d, three sides of the most economical trapezoidal section will be tangential to the semicircle. Okay, so the radius of the semicircle is the depth of the flow and center is the center of the top width. Center is the midpoint of the top width and radius is the depth of the flow. So that semicircle will have three sides of the trapezoid as the tangents. That is the most economical section. Okay, the conditions are b plus 2nd by 2 is equal to d into square root of n square plus 1, which we derived before. M is equal to d by 2, that also we have derived before. And the last proof which says that if semicircle is drawn from O with radius equal to depth of flow, then it will touch the three sides. That means it will be three sides will be tangential to the semicircle. So let's see a problem. A trapezoidal channel has side slopes of 3 horizontal to 4 vertical and slope of its bed is 1 in 2000. Determine the optimum dimensions of the channel if it is to carry water at 0.5 meter cube per second. Take chassis constant as 80. So in the question it is given as the side slope is 3 horizontal to 4 vertical. So we write as n is equal to horizontal by vertical. That is, for every 3 horizontal there is 4 vertical. Slope of the bed or bed slope is given as 1 by 2000. Discharge is given as 0.5 meter cube per second. Chassis constant is given as 80. Okay, for the most economical section, the condition given is b plus 2nd by 2 is equal to d into square root of n square plus 1, where b is the width of the section and d is the depth of the flow. So we have to find out b and d. So here the quantities we know are, we know n, that is 3 by 4, which can be substituted here. B and d are two unknowns. So if we substitute n here, we get b plus 1.5 into d by 2 is equal to 1.25 d. Okay, and if we solve that equation, we get b is equal to d, that is width is equal to depth of. Okay, so discharge is given by the equation q is equal to ac into square root of mi. This is the standard equation for discharge. But we know that for trapezoidal economical sections, hydraulic mean depth m is equal to d by 2. So here we substitute m as d by 2. We know the values of I, C and A. Okay, A 0.5 is equal to, which is the value of q, which is given in the question, a into 80 into square root of d by 2 into 1 by 2000. Okay, so area is given by the equation b plus n into d into d. Okay, this is the equation for area. But from the problem we got that b is equal to d and n is equal to 3 by 4. So we substitute these two values here, we get d plus 3 by 4 d into d. So this is finally 1.75 d square. Substitution for a is 1.75 d square. So we substitute 1.75 d square in the equation. So there is only one unknown in the equation, that is d. So we get d as 0.55 meters. That means breadth is equal to depth is equal to 0.55 meters. These are the optimum dimensions of the channel. These are some problems for you to try out at home. Thank you.